All right, everybody, here we go. So today we are doing your Unit 6 test review over Trig. All right, over here we have your learning targets. Remember, as you're going through your packet, if you're struggling with a topic, to highlight it, and that's when you know that you need to go back and study it. If you feel good about it, go over here and put a little check mark in that check mark column, okay? All right, let's get started. All right, first we're going to talk about converting from degrees to radians or radians to degrees. So it says number one is convert the angle from degrees to radians and show your work. So we're in degrees, we want to go to radians. Remember, we're using 180 degrees equals pi, right? That's half of a circle. So we're going to multiply by that ratio. Now if I have degrees in the top, I need degrees in the bottom, so then they cancel. So that just means pi goes on top. So this is really 135 pi over 180. And to type that into our calculator, 135 divided by 180, and then hit math frac to turn it into a fraction. So 3/4. So 3 pi over 4. Remember, we want your answer in terms of pi. Okay? Number two. It says convert the angle from radians to degrees. Show your work. So I'm going to multiply by putting pi in the denominator so then that they cancel. And then I'm going to put the 180 degrees on top because that's what I want to be left with. Remember how we talked about those unit conversions. So two different ways you can type this in. You could do 7 times 180 all divided by 3. Or you could do 7/3 times 180. I'm going to do 7 times 180. And then divide that answer by 3. Gotta be careful of how you put this into your calculator, guys. Okay. Alrighty. That's it for that. Alright, arc length. What is the equation for arc length? Okay, I actually put it up in your review up top. S equals 2 pi r theta over 360. I will give you the formula on the quiz, so you don't need to really memorize it. Just remember that theta has to be in degrees. Okay, if you are given a radian angle, you need to convert it to degrees first. All right, number 3 says find the length of an arc formed by a 75-degree angle on a circle with a radius of 35 feet. Show your work and round to the nearest tenth. So find the arc length. Find the length of the arc, so we don't know what S is. 2 pi. We have a radius of 35 feet, so R is 35. We have an angle of 75 degrees, so 75 over 360. And type that in your calculator. Round your answer to the nearest tenth, so we can actually type in pi. Oh, there's a glare from the light. Let me put it up there. There we go. So I got 2, hit second, and this arrow key gives you pi. 35 over 75 divided by 360. Make sure you use your parentheses. So 45.8, and we are in feet from the 35 feet radius. Okay? Alrighty, flip the page. Standard position and coterminal angles is where we're headed next. So if we have a positive angle, remember when we rotate, we're going to rotate up. If we have a negative angle, we're going to rotate down. Remember, you always start on this side of the x-axis, okay? You could also think of this as counterclockwise and clockwise. How to find the coterminal angles. If we're in degree mode, you're going to add 360 degrees or subtract 360 degrees. If we're in radians, remember, if a full circle is 360 in radians, that's 2 pi. So you're going to add 2 pi or subtract 2 pi. A coterminal angle, just remember, it's the angle formed, like if my angle stops here, if I add 360, I end up in the same spot again. Okay, those would be coterminal angles. All right, so number 4 says sketch the angle with the given measure and standard position. Then find one positive and one negative angle coterminal with the given angle. So let's look at letter A of 250 degrees. You guys will have a unit circle with you guys. So if you need like kind of help with what the where 250 is, but let's logically think about this. So we start here, right? This is 180, okay? Half a circle is 180. This was 90. 90, 180 plus 90 is 270. Okay. If I want to get to 250, I need to go about here, like 20 degrees less than 270, right? And that's it. Now a positive angle, coterminal angle, we are in degree mode, so I can actually add 360 to 250. So 250 plus 360. I got 610. And then to find a negative coterminal angle, I'm going to subtract 360 from 250. So 250 minus 360, negative 110. Beautiful. And you can keep adding or subtracting 360 until you get a positive and negative answer. All right, letter B, negative pi over 3. All right, well, I know when I start here that a full circle is 2 pi, so half of that would be pi, which half of that would be pi over 2. So a third would be somewhere like over here. However, we have to rotate down because it's negative. So I actually should have wrote this down here. If this is pi over 2, this would be negative pi over 2. It's the same distance, but we're going down now, which makes that negative pi, right? So if I look at my unit circle, I do know that pi over 3 is somewhere up here, but I got to go negative, so it's going to be about right here. Okay, and then a positive angle, I'm going to add 2 pi to that. Now careful, when you type this in your calculator, you don't need to type in the pi's. All right, so let me show you how you do that. So we have negative, think of this as 1/3. So alpha y equals 1/3 plus 2, 5/3. So this would be 5 pi over 3. Okay. And then a coterminal negative angle, I'm going to subtract 2 pi. So negative 1/3 minus 2. Negative 7 pi over 3. Okay? Just be careful typing those in your calculator. All right, trig values. How to read the unit circle. Ooh, sorry, my camera's spinning. All right. So real quick, just wanted to go over on the unit circle, remember sine is the y value. Like if I think of this, cosine, sine, those are how the coordinate points are listed. So cosine's x. Tangent is sine over cosine. So this makes sense, we're doing y over x. These you do need to know, okay? Cosecant is the reciprocal of sine. So this is 1 over y. Secant's the reciprocal of cosine, so 1 over x. And cotangent's the reciprocal of tangent. Now remember, the reciprocal is you just flip the fraction, so this is you could just say is x over y. Instead of saying 1 divided by y over x, that reduces down to that. Alrighty. So you're going to have problems just like this, where you have to read your unit circle. So it says evaluate the trig functions using the unit circle only. Leave your answer in simplest fraction/radical form when applicable. No decimals. So the first one we've got here, let me try to move this down a little bit. Okay, sine is, oh, sorry, this is spinning so much. All right, sine of 315 degrees. So on my unit circle, I'm going to find 315 degrees, which is over, ooh, got a glare, over here. And because we're finding the sine value, I need the y coordinate. So this is negative square root of 2 over 2. Okay, cosine of negative 180. So I got to find negative 180, find the angle first. So if this is positive 180, this would be negative 180, and we're finding cosine, so I want the x value, so negative 1. Okay, need to put this here so I don't spin. All right, letter C, this is cosecant of 7 pi over 6, so I'm going to be doing 1 over y. So let's find 7 pi over 6. Here's 7 pi over 6. I'm going to do 1 divided by negative 1/2. I want the y coordinate. So I'm doing 1 over negative a half. Okay? Now remember, whenever you're dividing by a fraction, you're really multiplying by the reciprocal. So I'm really multiplying by negative 2 over 1, which equals 1 times negative 2, negative 2. Circle answer. All right, secant of a negative pi over 2. So this would be secant 1 over x. Like I said, you guys have to know these, okay? All right, so here's pi over 2, right? So if that's positive pi over 2, negative pi over 2 would be down here. So it's right here at this coordinate point. And we are doing secant, so I need 1 over x. So this x value is 0. So 1 over the x value is 0. 1 divided by 0 is undefined, okay? Remember, if 0 is on top, it equals 0, but if 0 is in the denominator, it's undefined. You can even type that in on your calculator, and you'll see that it says error, okay? Alrighty, letter E, cotangent on 135. Well, cotangent is x over y. So where's 135 at? 135 degrees. All right, x divided by y. So I have negative square root of 2 over 2 divided by the square root of 2 over 2. Well, negative divided by a positive is negative. And notice that these are the same term, okay? Whenever you divide numbers by each other that are the same, that just equals 1. So you don't even need to go over here and do like multiply by the reciprocal and all that. You can, and it will equal negative 1, but work smarter, not harder, right? Notice that those are the same number, so that equals 1. All right, tangent of negative 2 pi, that's going to be y over x. Well, here's pi. This would be 2 pi, but I need to go negative. So this is negative pi, negative 2 pi. So I'm right here, okay? This would be, I'm sorry, what are we doing? Y over x. So the y value is 0 over the x value is 1. 0 divided by anything is 0. Okay, so you guys have to be able to find the angle in radians or degrees on the unit circle. I will throw some negative angles in there, and then you have to determine if it's the x or the y value or if you're dividing them. Alrighty, let's keep going. All right, what is the Pythagorean identity equation? Sine squared theta plus cosine squared theta equals 1. Okay, I will give this to you as well for your quiz. All right, given that cosine is negative 5 over 13 and we're in between pi and 3 pi over 2, find the values of sine and tangent using the Pythagorean identity. Show your work, no decimals. Okay, so first let's figure out what quadrant we're in. So this is pi, and here's 3 pi over 2. You guys will have your unit circle the whole time, so you can also double check that. So we're in this quadrant because we're in between those. All right, so this is my triangle. There's my angle. Okay. Cosine, if we think about SOHCAHTOA, is adjacent over hypotenuse. So this is negative 5, negative 13. Oh, I should probably change that. That doesn't make sense because they're both negative. Let's just change the quadrant. I haven't printed these out yet, so I'll fix it. Let's go from pi over 2 to pi. Oh, the hypotenuse. Oh, wait, no, that was fine. Oh, my goodness, guys. I'm so sorry. I'm struggling over here. You guys are thinking I'm crazy. Okay, hold on. I had that right. All right, 3 pi over 2. Okay, let's redraw that. Sorry. Okay, negative 5. The hypotenuse is 13. The hypotenuse is always positive. That's why that ended up being okay. Whew, sorry about that, guys. Alrighty, so we need to figure out what this the opposite side is, right? This is opposite, this is adjacent, that's the hypotenuse. Okay, we are good. Yeah, the negative goes on the adjacent side because this is the negative x direction that our triangle's in, and the hypotenuse is always positive, so that makes sense. Okay, whew. Now, like I said, we need to find the opposite side in order to fill in sine and tangent, right? So let's set this up using the Pythagorean identity. So sine squared theta, we're going to find that guy first, plus cosine is negative 5/13 squared equals 1. All right, so let's plug that in and simplify this thing. All right, negative 5/13 squared. Oh, don't want decimals, turn it into a fraction. Sine squared theta plus 25/169 equals 1. And then I'm going to subtract 25/169 from both sides, so that cancels. So I get sine squared theta equals 1 minus. You can either put it in as a fraction, or you could do 1 minus the parentheses of 25 minus, or divided by 169. Turn to fraction, 144/169. All right, now sine's not by itself yet. Got to square root it to get rid of that square, right? So sine of theta equals plus or minus when you take the square root of a number. So square root of 144 divided by 169, 12/13. All right, so now we need to decide if that is positive 12/13 or negative 12/13. Well, we know that sine is opposite over hypotenuse, which that makes sense. The 13 is the hypotenuse, so the opposite side is 12, right? And it's actually going to be negative because this is a negative y value. Okay, so that's how you determine if it should be positive or negative. So sine of theta is opposite, negative 12, over hypotenuse, 13. Okay, tangent of theta is opposite, negative 12, over the adjacent side, so negative 5. When you divide two negatives by each other, you get a positive. So it's 12/5. Okay, not too bad. Just make sure we know how to use that formula and how to solve. Like we know the algebra behind it, okay? Alrighty, let's keep going. Periodic graphs. Which of the following graphs, A or B, is periodic? Explain why. Graph B, because it repeats. Okay, over here, if I like take a piece of this and try to put it next to it, it's not the same function. But I can like put a box around one of these guys or a period and move it, and it'd be the same pattern again and again. Okay, so that's how you determine if a function is periodic or not. All right, number 8, it says use the graph to the right to answer the following questions. You will have a question just like this on your test, okay? Alrighty, so it says hint, draw a box around one period. Okay, so this obviously is periodic because it repeats. I'm going to draw a box around, let's see, all the way to here, right? If I pick up this box and match it up, this piece is the same as this piece. That's how I know how far I need to draw my box, okay? All right, the midline, it says what is the midline? Well, the midline is like what cuts the graph in half, right? So it looks like the x-axis does. So that's the line y equals 0. The amplitude is how many units above and below you are from the midline. Notice on this graph, each unit is 2 units, so this is actually a 4 here. This would be -2, this is -4. On your test, it'll go by ones, but make sure you do pay attention to that. So what's the amplitude? It's 4 units up and 4 units down, so the amplitude is 4. That's how you can double check your midline too. And then the period, remember, is the horizontal distance of your box, so from here to here. Well, each unit seems to be pi, so this is 1 pi, 2 pi, 3 pi, 4 pi. Okay? All right. And last but not least, we have your graphs. So you will have to graph one sine, one cosine, and a tangent graph. So real quick, it says state the amplitude and the period of each and draw the graph. Label both axes on every graph. So, sorry guys, it's early. All right, so the amplitude is 2. That's your A value. The period for sine is 2 pi over b. So I'm going to do 2 pi over my b value is 1/2. So this is really 2 pi times 2 over 1, which is 4 pi. Okay, remember, whenever you divide by a fraction, you're really multiplying by the reciprocal. So let's sketch this out. For sine, remember you draw 4 tick marks, 1, 2, 3, 4, and that's where your period goes. Okay, and then our amplitude is 2. Oops, -2, right? All right, and then the sine function, here's the pattern if you forgot it. Make sure you know your patterns though tomorrow. So sine starts here at the origin. Next tick mark is a max. Then we go back to the midline. And then we go to the minimum. Then we go back to the midline. Now I did forget to say, hey, what's half of 4 pi? 2 pi, right? If 4 marks is 4 pi, 2 marks would be half of that. All right, now connect your function. And you're done. Okay, cosine. Amplitude is 3. Period for cosine is 2 pi over b. Here, let me write that. The amplitude's A right here. Okay, so the period is 2 pi over, my v value is just 1. If you don't see something there, it's just 1. So this is 2 pi. So let's draw this up. 1, 2, 3, 4. 2 pi. That's my period. Fourth mark was 2 pi. So the second mark is half of that. So 2 pi divided by 2 is pi. And my amplitude is 3. 1, 2, 3. 1, 2, 3. Okay. Remember we start at the max. You have to know these patterns. These won't be on your quiz for you. Mid, min, mid, max. Connect your dots. Okay. And last but not least, we have the beautiful tangent function. All right. The amplitude is always none. Okay. Even though there is an A value here, remember tangent, it goes up and down forever, so there's no like max or min really cutting it off. So that's why there's no amplitude. So just be careful on that. Okay. It's always none. Always. Always. Okay. All right, the period is pi over b. So you do need to remember sine and cosine are 2 pi over b, but tangent is pi over b. So I have pi over, my b value is 2, so it's just pi over 2. All right, so tangent, remember we do 1, 2, 3, and 1 over here. So my pattern, I start here at 0 on the origin. Oh, whoops, I forgot to fill in my axes. So sorry, guys. Sorry. All right, so on the second mark, you write pi over 2. That's where you put your period. Okay. Then, sorry, just checking something. Yep. Okay. So then we go 0, vertical asymptote, 0, vertical asymptote, which means this is a vertical asymptote. And then you just connect and make a nice pretty graph. All right, so this is starting at the origin. Zero vertical asymptote, 0 vertical asymptote. All right, make sure you draw on that vertical asymptote over there. All right, that's it, guys. Make sure you guys study up and let us know if you have any questions. All right, see ya.